This week, we're going to begin our discussion of correlation. In the weeks prior to this one, we've been focusing on quantitative techniques, research techniques that are typically applied in experimental contexts, things like t-test, ANOVA, factorial ANOVA. These are usually used when the experimenter is manipulating the independent variable, and typically there are discrete groups of participants. So there could be a treatment group and a control group, a post-test and a pre-test, a placebo group, a no treatment control, and so forth. And these are the techniques that are typically used in experimental research. So the means are being compared, the independent variables are manipulated. That means the researcher is actually causing participants to experience different conditions. Usually the independent variables are categorical in nature, and the idea is to make a causal inference. Does sugar affect hyperactivity in children? To really address that directly, you would need to manipulate the amount of sugar that a group of children consume and then monitor their behavior. Not every research question is appropriate for an experimental design for various reasons, practical reasons, ethical reasons. Correlational research is comparing continuums. The independent variables are not manipulated. So the experimenter is looking for patterns, the researcher, I should say, is looking for patterns as they exist in the world, and they're looking to see what predicts what are the relationships, how can we come up with theories to explain patterns of behavior. But causal inferences either aren't made or they're more difficult to make. It's not that you can't make causal inferences, but it's a lot tougher. The independent variables are continuous in nature. There are some designs where you can incorporate dichotomous or categorical independent variables, but at least one independent variable, your key independent variable, is continuous, and your outcome variable is continuous. In fact, with all of the different tests we're going to be using in this class, the outcome variable is always continuous or scale level. If it were not, we'd have to use a different type of test. So some research designs, statistical designs that we'd use within a correlational framework, or correlation analysis, that's what we'll talk about this week, and regression. Okay. So patterns of relationship. Well, one possible relationship is no relationship. That is to say, if you know the values on one variable, you know nothing about the values on the other variable. So for example, if we have a plot here of height versus chess ability, unless we're dealing with children, in which case as they get older they are cognitively developing, but if we're dealing with adults who are already matured, someone's height should have no relationship with their chess ability. Someone who's very tall could be average, good, bad at chess. Someone who's very short, likewise, could be good, bad, or average at chess. So if you know how tall someone is, you really don't have any real guess of what their chess ability would be. In fact, the only guess you could make would be the mean. So if you know that the mean chess ability is here, let's say it's 0 to 10, here's 5. If you have a short person, you say, well, what do you think their chess ability will be? Well, I think it will be 5. That's the mean. That's my best guess. The person is 8 feet tall. What do you think their chess ability will be? Well, I still think it will be the mean. That's the best guess that we have, okay, because there's no relationship. Okay. Another possibility is a positive relationship. And this means that high values on one variable are associated, of course, with high values on the other. So an example would be years in school and salary expectation. The longer you stay in school, the more money you're likely to make. The sooner you quit going to school, the less money you're likely to make. So knowing how many years a person has completed in their education does give us information with which we can predict that person's salary. So we can say that if the person has been in a school a long time, we can predict that they will make more money. This person dropped out of high school, they're probably going to make not a lot of money at all. And then in the average, it would be more towards the average. Another relationship would be a negative relationship, or what's called an inverse relationship. And this means that high values on one variable are associated with low values on the other. So an example, self-esteem and paranoia. Somebody with very high self-esteem would have a low level of paranoia. Somebody with less self-esteem, a high level of paranoia. So it would have a negative correlation, or an inverse correlation. Finally, we have a curvilinear relationship. So this is nonlinear. These are linear in nature. This one is curvilinear in nature. And so the there is a it could go up and then down and up again. So dosage level and severity of illness. So a low dose, you'd have a lot of severity in the illness, and then you'd have, I guess, the proper dosage, and you would have a low severity of the illness, and then you might overdose, and perhaps the severity goes back up again. So the relationship changes over the range of both variables. Another example of this would be perhaps test anxiety and test performance. If you have very low test anxiety, you'll have very low performance because they would look the other way, be flipped around, because you don't take the test seriously. If you have a middle level of test anxiety, you'll have the best performance because you're going to be focused, you're going to study, you're going to be attentive. But if you have too much test anxiety, then eventually your performance goes back down again because you're too stressed out and you can't pay attention because you're too anxious. So it would be upside down. It would look like this, or at least it would be the inverse of this one, like that, curvilinear. Correlation coefficient. So the way we represent a correlation, or we talk about the strength and direction of the correlation, is with a correlation coefficient, usually represented by the letter R, and this measures the strength and direction of a linear relationship between two variables. So they range from -1 to 1 and everywhere in between. So 0 is there's no correlation. Anything that's positive is a positive correlation. Anything negative is a negative correlation. A value of 1 or -1 exactly is a perfect correlation. That means the value of one variable can be perfectly predicted if you know the value of a second variable. So this would be true in more of the hard sciences in many cases, but in the soft sciences this typically is not going to be the case. We're going to have a correlation somewhere between 0 and 1, or between 0 and -1. So let's take a look at some examples of this. So fifth graders' height and weight. What kind of correlation would we be looking for? Well, there should be a correlation, so it shouldn't be so low, say 0.02, that's like nothing. And there should be a pretty significant relationship with fifth graders as they're growing. They're still little kids. And it should be positive, right? As you get taller, you should weigh more because the kid's getting bigger all around. But it wouldn't be 1, that's a perfect correlation. So it might be somewhere in between. So maybe a 0.65, 0.4. I don't know if it'd be as high as a 0.78, but it'd be somewhere in the mid-range of a positive correlation. Self-esteem and drug use. Well, it's going to be a negative correlation, right? As your self-esteem goes up, drug use goes down. It wouldn't be a perfect correlation. Maybe something like a -0.3, maybe a -0.5, not sure if it'd be quite that high. Probably somewhere around a -0.3 would be what that might look like. Intelligence and shoe size. Well, assuming the people in your sample already matured, there really shouldn't be any relationship at all. Now, you're seldom going to see an exact 0 correlation, but that might be our 0.02. It's not significant, it's just a very small correlation, and so forth. So you can take a look at the rest of these if you'd like and try to get a sense of where they would go. But that's basically how this works.